Thank you all for joining here. Today we are going to present a topic about that how we built an enterprise cache using the CQRS. I think this is something what we have done like 2 years ago, and this is I would like to present here. And there are so many things, improvements also we can make. So while we are discussing that, we all go through that some of the patterns what we have followed. It's about me. I'm Komes Subramaniam. I work for a T-Mobile and digital technology and development organization. Mainly, I'm responsible for an architecture and then framework development and then some of the prototyping, pre-OC concepts, what we do it there in our organizations. So we recently created and announced our open source community. That's open source community where we bring our internal talents and we make products. Some of the open source mindset products we have created it. When you get a chance, please go and visit our open source t-mobile.com. That is some of the products we have recently published. You can play around with that. Apart from the work life and coding, I love running, biking, and spending time with the family and friends. So T-Mobile, I think many of you guys familiar with the T-Mobile, how we have transferred the industry from 4 years ago and how we have gone for so far and how much customer growth. It is all kind of main reason our senior leadership, how they drove the company. And we are right now, we were like in a fourth largest national wireless industry. Now we are third. We kind of more than 75 million customers we have it at present. We kind of picking a pain points of what wireless customers, what they have it, and that is something what we have done, changed that industry with so many uncareer moves, what we have done for past 4 years. These are some of the uncareer moves where we have unleashed so many way of taking away the pain points what wireless customers have it. Recently what we have it is a Netflix on us. This is something which many of you guys familiar, where we provide a Netflix service free. All these things, how we started it, right? So when we started from any customer or any retail industry, we start from the retail store. First, we begin within a retail. We started serving in customers for the retail customers. Then we started attending the customer once they are away from the retail stores, and we started hearing that are serving the customers through customer care calls. Now, there is more needs comes up. Now, where we go for online services, that is something online services where we start serving to the customers through our online portal. Now, with a mobile smartphone launch, there is a smartphone apps also we have launched it, something we serve through a mobile phone. Now, when John Ledger introduced, when he came to the social, this is something we started serving or helping customers to reach out to customers. They can tweet, or they can reach out to any time. Sometimes John Ledger handles the customer care calls. So he listens to the customer and he files a ticket for us, and then we go and resolve that. So we are kind of on recently, I think we got all three spectrum. I think we got JD Power Awards for our customer satisfaction. So we are kind of number one in there. So the point what we are trying to make here is we listen to the customers and we stay connected to the customers. There are more and more ways to listen and then connect with the customers. So now applications are growing. What you see is actually a number of applications. What you see here, the more application we present the user data and customer data to the users, it's kind of it's a read starving, right? We read a lot of data. And we changes what we make, and when you compare to the read, it's a lot less compared to that how much data we read from our database. So we do have some legacy, or I would say that some of the systems what we use it from our vendor products, we still need to work with them, and we need to rely on that product, and they are kind of successful on the behind the scene for for example, billing or our shipping. Our inventory, all those things we rely on some of the legacy systems what we have it in our side. These applications reads the data. I think maybe this is a recent message or help where customer sends a message and immediately they look up the customer information and they provide that information, what they are seeing it, and they can help them immediately. That's something what you are seeing there. Now, every read application is doing that. If you look at every API or every service call, what it is invoking from an UI perspective, this is something what I don't know how much of you can see from the page. This is one of the landing page calls in our recent application. You can see that the landing page makes 4 different calls, 5 different calls, and underneath that it all goes down to another level of layer where it makes underneath the legacy system calls. That legacy system calls make another kind of a set of underneath the product queries. So this is something you would be realizing that the more and more data what we read from the legacy systems, and then more and more data what we kind of repeat and show that information for every application, it's kind of it's a lot of data what we read in the legacy system. It kind of needs to have scalability in your legacy system also. So this is kind of causing a problem of page rendering takes a lot of time to render it, and the resource utilization on the page, it's really high, where if you want to scale that system, your legacy system, something you have to increase the CPU, start from the bottom, and then you are increasing that scalability here in the legacy systems, and also in the top layer, in the middleware layer, and then layer above that, UI layer. So we all the way to increase our systems, and think tenfold. Sometimes when we go for an iPhone launch, we increase it tenfold to handle the traffic. So this is what we wanted to show, that so in a quality user experience, so the user don't want to see that spinner. That's what we want to show. It doesn't mean that you can put another spinner. So basically what we are coming up with in a solution requirements is we really need a significant performance improvement. That's a key point what we wanted to see. And the solution, it should support a high volume of traffic. That's a minimum requirement for this is to handle that your mobile traffic, this is to handle your Twitter traffic, or any care or retail calls, or any promotions. That is really a minimum requirement. And also reduce that operation cost, which is when you increase systems, when you need a scalable system, you should not be looking at the system underneath that there is a legacy system, which is something it can handle like 200 requests per second. If you want can handle like 2,000 requests per second, then your kind of cost of increasing or scaling that system is really high. When you are dealing with even from some of the SAP systems, I think many of you guys face that problem. The server side increasing that, and you have to work around the database and how we are going to scale up the database, and how there are some of the database replication mechanism. It takes hours of time to do that, even for a simple read data. And we want a solution which is the data should be consistent and it's in a usable manner. So that's also, if you look at the previous screen, what you have seen that there are so many reads what we get it from the backend systems. We want a simplified data model, which is a read query friendly data model. That is what we want to get that. So this is something very minimal requirement for our solutions. What you would be coming up with okay, yes, we want to make a data model which is very friendly data model. At the same time, we want to have a data consistency. These are the things where something in a design level or developer need to work on that and to understand what needs to be done. These solutions, some of the solutions, some of the requirements, yes, we can meet within a response cache. So solving with the response cache is one way of doing that. We have, from the past decades, we have dealt with that. And we have resolved so many problems within just simple implementing the response cache. For example, some of the web page content, for an example, phone page information. If you want to display the phone page information, we could make use of the response cache, and it will solve your purpose. Where this is kind of sends a request. If you don't find it in the cache, I think, and then it will reach out to the data storage, and then it's load it in the cache, and then it returns back. Sometimes if you are dealing with a data which is dynamically can be updated, this solution may not be suitable for you, because this cache will be updated based on anything is in a timer based, or if you have to invalidate, it's kind of on a force invalidate that, or some kind of eviction policy you have to implement to clean up that cache. There is the response cache. It doesn't get dynamically updated in your cache. What you keep it in your closer to your UI layer. So this is something in a fairly static data. What we deal with is it's in a fairly static data, which is in a phone information, phone image, those kind of things. What we deal with it. Now, yes, if we don't solve the problems what we have within a response cache, what is another alternative? So that's where I think 2 years ago we looked at that the CQRS pattern, which is command query responsibility segregation, where the command meant for a write. So you make changes into the data. That's called command. So the command is something we separate it out from how we read the data. So we are separating the write information from the read data. So the write information, it's not about just separating the two systems. It is sometimes it makes sense to have a different data model itself. So the different data model, when we talk about different data model, yes, I think there are basic concepts you could think of: normalized view, normalized and denormalized way. So the normalized way, any legacy systems or any product what you buy off the shelf, most of the tables or storage structures are normalized. It's fully normalized, and its storage, how we keep the data, it's inside that systems. It is how we store. It is efficient enough for how to write the data, and also it's a less amount of storage. Now, we deal with how we read the data. So the read data is completely, it's going to be in different how we present the data. There are multiple views you can present the data. So what we are going to focus on only that the data how we want to read. So how the models would be in a kind of created, it's friendly to the read. So what you are looking at here, the data what we read is from the query data. From an event handler is something where we collect the changes from the write activity, and then we ingest it and transform it, and then we store it in that query data models, and then so that it's easy to read the data, and also it will be performance will be efficient for you to meet the UI requirements. So what we see is the benefits. This is where we started, like some of the things, there are pain points in the legacy systems. We optimized our queries enable with more scalable reads. So when we do this way, the write data what we have it, we don't need to worry about how much of write we do it in the system of record, because we are dealing with only the less amount of writes. So the read is more often, more queries would be coming here. That is something, it's really scalable to meet the need for what UI wants it. And it's in a call latency, it will be reduced drastically. And the productivity of the developer who are writing the client apps or mobile apps, that will be an increase. They don't need to understand that, or they don't need to deal with hundreds or thousands of fields, and it is it's very friendly to that UI how they want to get the data. And offloading the data, this is I think indirect benefit what you see that, where offloading the read data from the write, it's kind of you are externalizing the data. So you can move this data, what you have externalized, to a cloud space or on some other external storage easily. You can move the data to a different data center, or you can easily increase the scalability. That is in a way that it benefits your legacy or a write or command how it is serving the system. You don't need to worry about scaling that system in a higher cost, which would be essentially it's a more time consuming, and also it's a more resource intensive for that to increase your system of records. These are the immediate benefits what we would be seeing that CQRS. I think so. That use case what we pick, it's when we show that our senior management agreed that okay, that looks okay, kind of looks okay to me that why don't we do it in a smaller scale. So we started implementing, I think this is like 2 years ago. What we did is just picked an order status. So we want to show an order status. We do have a system which handles our orders, and we have a system which handles the trading device information. We do have that's a different system, and we have a system which handles our product information, the shipment, what we do it, and also there is a customer information. Now, to simply present this data, these are some requirements what we have to show. So from the business requirement, we want to show the order status to the customers in a easier way. And when we look at that, he don't need to decrypt the messages, what we are putting into that. Okay, there is a date, something like that. So it's in a friendly manner how we want to present it when somebody orders a phone. So why don't we provide the friendly name for the user, what we associate to that. And that service should be really fast enough. And also that high volume request, we need to handle that. So the typical implementation we would have done before this pattern, we write an API for an order status. That API would be go and query from the product reference data. Okay, this is the device. Okay, this is a SKU, and for this SKU, what is the device he is ordered it, and then subscriber information. Basically, what is the name? We would be associating you with your mobile number, and then order management, where your order is created information. Then you know that whether order is in the created state, what is the back order state, or is the processing state, and trading. Along with your phone purchase, you might have done some trading where you need to ship it back to our company, so that we will be giving that credit back to you. And the next one is that network elements, where once your device is shipped, then there is an activation. We put that your associated number into the networks also. That's kind of an asynchronous process. So all this information we need to collect in a real time. When you ask for this data, then it goes and grabs the data and then presents to the UA. So this is what we used, the typical implementation, what we used to do. Now with this CQRS, this is what we do. What we did in this, basically we started collecting the events. When the order management started created, once the order is created, we started getting an event and a trade-in. Yes, when there is a trade-in is posted, we started getting an event. Subscriber profile, we started getting an event where we change the names. So now that events were collected and then ingested through an event handler into a read-friendly manner in the query data, which is kind of a fully denormalized data, what we store it in the query data, which is really exactly the matches within a data what the user wants. Basically, when the SKU comes from the order management doesn't send, okay, for this SKU, this is an iPhone. So we have to associate with a reference data. We enrich the data, and then we ingest into with an exact name of the product. And a trade-in also, sometimes that device, what they ship it, you may not find all the devices in that in the reference. So we have to go into that our reference data, and sometimes external source, we import it. Our vendor is an assurance, so we import it, and then we will have a reference for what kind of a product he shipped it. Now, this query data, what we store, it is kind of close to that what the requirement, what the business was asking. Exactly, that's matching with the requirement where we want a subscriber who ordered, when they ordered the phone, this is a line, and this is what the phone, and this is what, when it is ordered, what is the status on that. It's clearly, it is kind of, we are able to give that information. Now, I think that is what you would be seeing that, okay, this is the shipped information, estimated delivery, which is, we are getting it from the UPS, and then Apple iPhone 6s, and then what kind of color it is, and then that, what is it, specification, which is in 32 GB, and for whom he is ordered. It's a John new device. This is what we were showing that. So that implementation, what we did, it is actually, it's a Spring Boot. We used a simple Spring. And then Spring Boot, where I think we wrote on our event handlers. Event handler, it's just which receives the message. The queue, what we have, it is in a legacy EMS queues, which is in a TIPCO implementation. The JMS implementation, we were using that. And Spring Boot, and I think it was very easy to write. I think 2 years ago also it was kind of quick, and then it's the whole development we did it in 3 or 4 weeks. We put it into the production. So it was easy to do that in the event handler or writing any API. It was very simple. And for a query data store, we used a Cassandra because there were a lot more events were coming. We were expecting that, okay, there are some more use cases. And also the structured how we denormalized way. We felt that it's that time as a Cassandra it wasn't that our available, and then we started using that for Cassandra. So this is a read optimized model. When we transform the data, what you see is from an event stream we get the data. This is from a normalized data to how we denormalize the data. So order information and order data, and then all the information how we are putting together. There are some information we have associated to the product enriched data also we would be writing into the normalized data model. So the next use case what we picked up, which is a little bigger than what we deal with it, which is an order set, we moved to subscriber details. The entire subscriber details, why not we get it from there? This is something, it's after the success of what we have shown in the order status. Yes, this pattern works, and we can do something more than that. It doesn't mean that CQRS fits for all the use cases. CQRS, it really gets complex when you deal with some of the models and how the systems, how it works. But we want to try it out with the subscriber details with the same kind of a model where our systems, where our building system was holding the most of the subscriber details. So, and there are other order information, because now we have an order information and we know that, hey, recently you have placed an order, and we should be providing that information along with when we provide the data along with the mobile. So this one, mainly we want to provide the essential data, which is in a billing information. That is what the most of the people used to see it in the phone. Okay, what's my bill, which is changes only once in a month. That is very rare. I would say that it is not that frequent. Yes, every day we get like millions of data. That doesn't mean that from a customer single subscriber perspective, it's just once in a month event. So what you see that apart from that, there are some usage information also. You would be seeing that usage information. It caused a lot of problems where we started sending the data, and then customer, when they get throttled, they reported back saying that, yeah, this app is showing something, it was not latest and greatest, even though everything is an asynchronous model. And that's then usage model, we kept it aside. Okay, it's not going to work for us in the event model because there isn't a delay for that. We just moved aside from usage, but rest of the information about your plan, subscriber information, everything we pulled that, and even if your finance information, which is when you buy a phone on the loan, and we got that information here. So with that, this is what that basic implementation, the model how we had it. So that in a normalized data model, what you see it in a customer can have a multiple financial account. Then each financial account can have multiple lines. Now it's transformed to now how you are making a query or how you are going to read the data. As I said earlier, each customer information or customer changes can be combined into a single row, which is kind of in a logical sense, what I'm trying to say. In a write sense, it may be in a more than one rows, but in a read sense, it can be represented in a single row. So we transformed all the FAN information, which is a financial account information, into a single row from a read perspective, which can be queried within a customer ID, or the other way, for each account, there are multiple lines we associated. That's from you can query within a line, account based also. This is a read optimized model what we have developed. Now, how we did that, this is an implementation. What we had it, we continued along with it, and we added a couple more systems in this. As you see that, we added billing and charging, and that's a system where we get billed, and then payment systems where we get the payment data. This all we got into the event stream. And event handler would be consuming that and transforming it to a different model in a query-friendly data model, and then it is publishing it to a subscriber service. So with this implementation, this is what the results we have achieved. What you see it is that API latency, it's 99.9 percentile. We were used to, I think this is initial launch when we did that within a device, T-Mobile app device. It's a 32 milliseconds for a 99.9. I think you can see that the rest of them in the 95, 99, something it's in less than 10 milliseconds. This is an app level, not from a client perspective. So what we really achieved from this, it's in a very quick solution what we want to achieve with a legacy system in place. At the same time, we externalized our read data. That data can be moved around with any cloud solution also. That's a basic principle. Once we start moving around the data, the scalability is very easy to do for that. And we optimized our data, how we store it for a read purpose. This is actually, it is very useful for our UI application when they code it and they know that it's easy to map it to their UI, and they don't need to go through hundreds and thousands of fields and map it to that. And it's replicated in a cloud space, and you can scale it and however we want it. And if there is any promotion happens, you can scale it however we want. Maybe it's easy to increase, and the cost is significantly reduced for this. Some challenges, I think you may face this when you implement in your organization similar way. Initial data migration, you may ask this question maybe how did you do that initial data migration? We did not do initial data migration. Basically, initial data migration, it's a time-consuming process, and also it's a lot of effort it requires. When you do a migration, there will be a drift will happen. So that's why I think in initial migration we don't want to do, because when we try it out this solution, why not we do it in on-demand initialization? That means when you turn on the device, there is a login event. We started capturing it. During the login event, we considered it as a seeder event. That seeder event went and replicated the entire data into our storage, which sometimes it was kind of it was taking like 6 seconds or something like that. But the login events, as soon as complete, then we will have the data. That's one way to solve that. The other one is the first time when there is pick an event. Okay, there is some changes happened. Yes, I want to get that event, everything to be populated. So use that event as a kind of a seeding event for your read query model. So use that one. So other challenges, if there is a delay in the event, what will happen to this? Yes, because currently we are all subscribing to legacy systems events. What if there is an enrichment happens? We cannot just hook up in our middleware service where it makes writes into our system, legacy systems. Instead, some data, for example, some of the additional services are added by our billing systems. So one is something like if you add a line, the billing system adds something else. So there is a data enrichment happens behind the scene. How do we bring that data? There will be a latency onto that. So one way to do that is we made that the middleware system to make it as a dirty flag in our read query model, so that when the read call comes, we say that, okay, this data is not good for writing. So what we do, we don't want to read that, then we go back to the backend system to query that kind of a data until we get it refreshed. So the dirty flag is set by another middleware until we get the data from the backend. So this is actually, works well for some of the events what we do. But right now, what we have it is for a key data where is plans and services. That's a solution we have it for this implementation. And also there is another thing I would like to mention, that this data when we write into that, there may be too many writes you may happen it. Sometimes you may need to do an aggregation on top of that. That logic, we just push it down to an event handler. That event handler was doing that some kind of an aggregation value here. The confidence. How did we bring the confidence? I know that once you externalize it, there is a confidence level, we need that. So this is one of the kind of video I saw that let's say that you are, as everybody is a software engineer, you wrote in a system which is kind of controls in a machine. It's a big machine, and then would you be standing in front of that? That's kind of a conference we need it for a software. So I just kind of playing for an. I think it was a funny video. There were the bunch of engineers. They were standing in front of the tank. They built a braking system for the tank. So the tank was coming down, and then they were all standing there. If the brake is applied, and the right in front of them and then back to them, and they were not scared. So that's a kind of a confidence when you build a software. So you put it out there, and you want to kind of that confidence. We need to have that. So how did we build a confidence for our team or leadership or the UI team? We did a pilot testing, and also automated real-time data comparison. So how did we do that automated real-time comparison? We put it into the production, and it's running. Still, it will be running for you, but at the same time, it will do a real-time comparison, and then it will compare that legacy calls once in 5 minutes or once in 2 minutes. There is a scheduler wakes up and picks up that whatever the record it is queried, and then it compares that legacy system calls and the data what we have it in our side. It compares the two data, and then it sends out the results. So daily we look at that report and make sure that our confidence, increases our confidence level, and also it's our senior management would be relying on this solution. So some of the guidelines, how we followed that. It's an API consumption. This is like if you are API consumer, if you know for them, and for example, specifically for an internal users, design the model which is actually meets the requirement. I think don't design it very generic enough, and some of the models what we read, it's read purpose. You design the model, it's specific for them. Yes, there may be multiple views maybe is required. And also some of the search keys, if you want to really short or minimize the storage, the search keys you can put it in a different index, and then indexer would be searchable faster enough. That's another way of keeping that if you have multiple search keys. For example, you may have phone numbers, you may have your address, social security number, anything. So what you have that. So if you have multiple information to query, multiple keys to query that same information, you just keep it in the separate space. And the primary focus, use the JSON format. Sometimes you don't need to separate that out. You just store that JSON as is, because when you modify it, the entire JSON gets invalidated. That's the one way of doing that. So deal with only the JSON. I know that there are legacy systems can understand only that XML format, so you can do with this. And in CAP theorem, this focus on availability and partition, what we focused on. So that's something actually when you design that, initially when you have it, make sure that your system is available 100% and it is scalable. That's a primary objective here. And as I said earlier, be cautious to use CQRS. CQRS is not for all use cases. Sometimes, and separating that two different model, it will create a complexity. The reason is when you write something into that and different model what you are following it in the read, so it creates a complexity within your system, and you may not be, you will be dealing with a syncing up or resync or reconciliation process issues. So pick a use case which is very simple for you and use it in here. And again, that's, I think this is Yagni, the picture you are seeing that. So don't pick that. You're not going to need it for all. So it's a Yagni approach. You can follow that. That's it. Happy to answer your questions. Yeah. Do you have mic? Yeah.
Is that a separate query data store, or would you ever reuse that query data store for the UI?
Yeah. So, yeah, it's kind of a pair together. If you are on a new API, yes, you will be having to deal with another storage. Definitely, it's an external storage, and the new API what you wrote, it is something, it will be talking to your new domain, new storage. Did I answer your question? Okay, yeah.
So for your query data store, that's not a full list of your, like, on a replica of your system directory, right?
Right, yeah.
So it's a queue, so when a user logs in, you fire off the events from the data store to fill your query.
Yes. Fill your data, query data.
So instead of hashing it through like REST call or whatever, you're just hashing it through events.
Yes, so through an event, so we get that as an event because we have a system of records which is legacy systems, and then when they send an event, you may not, what you have it, you don't want everything else, everything in the data. So what you need is only the data what you needed, you just write it into that, and you provide the data from on top of that, query API on top of it. Yeah. Yeah, when the changes happen, sometimes it's a delta, sometimes the entire event. So it's based on your system. Underneath that, it's a legacy system, what you deal with it. So you, initial load? Yeah, we did not do initial load. So it's kind of an on-demand. So it's on-demand based. When you see a need, when you see that, okay, there is a data required. For example, the first use case in order status, there is nothing to do, feed that. But at the same time, for a subscriber data, yes, there is a need for an on-demand initial load. But even then, we used a login event. From the login event, we started getting the data, and then we start keeping it. Then after that, subsequent changes, whatever we have it in, that event will be flowing through that. Yeah.
How do you ensure consistency between the cache data and your system of record, and what do you do when they get out?
Okay, right. So that's good. So when we started initially, as I said, the pilot testing where in the production we started running the both. We made a request to this instance. It will immediately reply back, which is 1 millisecond or something like that, because it was not responding back to the UI. But the data input, what we got, behind the scene, we started querying that system of record, and also we started querying from the read query, what we have it. We compared it. We took a JSON, two structure of JSON output. We compared it. If there is a discrepancy, we find it, we start recording it. So in a real time, when it happens, something happens, we kind of disabled it, like we kept it TTL for kind of a month, so that we will be kind of safe enough. Okay, there is a data, we are discarding it, some of them. So when we started with that to gain a confidence, that's one way of doing that.
Do you have an ongoing process to check that data over time?
Yeah, that's, yeah, no, yeah.
Just following up on that question, so you said like 2 years back you had the option of putting that down,
Right.
If you had to design it today, you would keep something like a Kafka, which would support these kind of capable, which is already exists your data store.
I think there are, it depends on how how your legacy systems are supporting and how you are writing it. Today we started writing in, there are so many microservices what we have it. So we started writing itself into the microservice, then event is getting into that system of record. So that's how we are doing it. We changed that some of the use cases totally to, okay, we have a microservice which will have its own storage. Then later on, the event is kind of communicates to the system of record. That's, we changed it. So now we write a query and then we provide an API on top of it. That would be consideration. But the same solution, if the same thing what we have it, and if we write it, maybe I would be picking some IMDb, what we have it here today. We have a Gemfire today, so we would be using that. Yeah.
I think you reduced the number of read transactions that you could, if it's still a passive solution.
How did you reduce?
You reduce the number of reads if you still need to read it every single time someone logs in.
Oh, someone logs in only one time you are reading. Okay, I thought Mike, okay. Okay, the question is, how do you reduce the read if every time when you're querying it, whenever you log in? So that's the question, right? So we are not reading it. This is the first time when we do that. for an initial launch. After that, we started taking the activation feed, which is when we onboard the customer. So the moment you install your app, there is a login process you will be going through that. That time we started seeding the event data. So it's kind of once. How many times you would be installing that? That's all. So we don't do it in every time. Yeah. What was your JMS provider, right? Oh, okay. So we have this legacy system. We are using the TIPCO EMS. That's what we have it in house. But right now, we all kind of moved to a RabbitMQ. RabbitMQ, yeah.
When you, let's say you're building a query model, and at that time you're having problems actually committing to the query model database itself. So you read events off the store, and then you're having trouble committing. How do you handle like replay of those events or redo of those events?
Okay, so it's a simple retry mechanism. We have it right now, but we never faced okay, there is a problem in writing that, but we just do a retry on the read. Yes, I do see that there will be chances of getting a discrepancy, data discrepancy there. But what we have used only the retry mechanism currently at present to deal with that. There is no other sophisticated mechanism, how other ways to do that.
Just a follow-up question, right? Because you're probably correlating multiple different types of events into the query model. So if you're having a retry on one fail and then you have a subsequent event come in which is a totally different event, how do you keep consistency of that?
Right. So that's a good point. So how do you keep that consistency between when the multiple events? Okay, so first you would be really in a good understanding of your domain, which system really responsive for which data. So that system is not going to replicate or it's going to retry that, and you have a timestamp from that event. So when other system sends it out, it is not conflicting with the data set what the other system is sending, because this system, for example, your payment information is something, it is the finance system is responsible for your payment information. Your billing data, billing system is responsible for that. Even though they have some information which they will be sending it out, you wouldn't be trusting that system. Oh, this is a system I would be trusting, I will be rewriting that. So you wouldn't be worrying about the other system, how they use it. So you just use it for the key, which is in your customer ID or in your financial account number to correlate or associate that account record to create multiple records. That's how we do that, so that there will be less conflict of interest on the different data. So you wouldn't worry about, yes, they do have a certain billing address information in the finance also, but I would be really focusing on the system who is responsible for the billing account. That's what the data I would be writing into that. Is it answered your question? Okay. Yeah. Any other questions? Yeah. No, the reconciliation process, yes, I do have familiar with how we need to handle the reconciliation. It's a really nightmare. Anywhere you replicate one system to another system, the replication is. But in this case, what we did is kind of we set an initially smaller TTL so that the data will be sitting there and then it will be gone for after time. So until you gain a confidence, there is no reconciliation. We didn't build that. So. Right. Yes. Some of them, yes. There will be rare cases where your customer data gets discrepancy. But I was thinking to kind of use the dirty flag way, where we think that, yes, dirty flag, and mark it out, and then it will be wipe out the whole thing. Yes, it's kind of operational things, what we have it, but we did not implement the reconciliation, and I don't want to implement the reconciliation also. Yes, but how do you reconcile with then you will be end up running multiple times, and then every day batch and all those things. We do have a reconciliation with some other provisioning activities where we deal with 6 systems to reconcile that. So that's a nightmare. Yeah, anything? Okay, thank you for your questions, and thank you. Thanks for your time, guys.